Okay, so continuing on, video number 2. So here we have question 6. A particle P is moving along the x-axis at time t. The velocity is given by, let's write it out, 3t squared minus 23t plus 30. Now find the value when it's at rest. At rest, that's when the velocity is 0. So therefore 3t squared minus 23t plus 30 equals 0. So 3t and t. Can we factorize it? So we have 3, so 6. So we have 3 and 10. 6 and 5, 5 and 6 as the most likely options. So 30 and 3, nope. 9 and 10, nope. 15 and 6, no. 18 and 3, 18 and 3. So it's going to be minus 5, minus 6. Okay. So now we know minus 5, minus 6. Find the values for t for which a is 0. So since the coefficient of t squared is positive, that means the graph is a happy graph. When it's a happy graph, we're looking at our roots are zeros, and it's a positive when it's less than the lower root or greater than the higher root. So t is 5 over 3 and 6. So our range of values when a is greater than 0, also the values when is that part B, sorry. Find the range of values for which a is greater than 0. That means we want to know when the acceleration is positive. So when the acceleration is increasing is when the gradient is getting bigger. So that's in the second half of the graph. So that's anything after the root, or the lowest point. So you know the lowest point of a graph, or the axis, is minus b over 2a. So minus b is 23, and 2a is 2 times 3, which is 6. So the range of values of t for which the a is greater than 0 is when t is bigger than 23 over 6. Final part C. When t is 0, p is at the point with coordinates d0. Given that when t is 8, p is at the point 26, 0, find the value of d. So we're looking for location here. That means we're no longer talking about velocity, so we need to find the value of the distance. So v is 3t squared minus 23t plus 30. So then our value of s is going to be the integral of v. So we're going to add 1 to the power and divide. So it's going to be t cubed minus 23 over 2t squared plus 30t plus constant. Okay, so we know that when t is 8, p is at 26, 0. So when t is 0, our point is at d0. And when t equals 8, our point is at 26, 0. That means we're at the beginning, we're at point D. So if we put t equals 0 in here, s equals c. So let's just change that to d. And we know when t equals 8, we're at 26, 0. So you substitute t equals a into your equation, and you know the distance traveled is we've gone from d to this value 26. So 26 minus d is the distance traveled. And we put a in there, so it's 8 cubed minus 23 over 2 times 8 squared plus 30 times 8 plus d. And you can rearrange and solve that for d. Let's have a quick look down. So that's question 6c. And you get correct value of d equals 10. Okay. So minus it's just 26. Okay. So I'm just going to shrink this down to make a bit of room. Okay, question 7. So we have two equations, f of x and g of x. F of x is 2x squared plus px plus q, and g of x is 14x squared plus 37x plus 14. The equation f of x equals 0 has roots. We've already done this together, haven't we? I'll come back to this at the end. Let's move on to question 8. Given that x is measured in radians, complete the table of values. So most of you did a pretty good job with the table of values. So just straight up calculator work. You've got minus 3.5, minus 1.6, 3.5, and 2.4. Plotting those on the graph, you have 0 minus 3.5, 0.5 minus 1.6, 0.8, 0.3, 1.6, 1.6, 3.5, 2.4, 2.5 minus 0.8, and 3 minus 3.2. So you get a graph that looks something like this. Okay. Using a formula from page 2, show that. So the formula you're looking at is cos A plus B is cos A cos B minus sin A sin B. And you're going to let B equals A. So that will be cos 2A is cos squared A minus sine squared A. But in our equation, we don't have any cos's on the right hand side. So we know that sine squared A plus cos squared A equals 1. So we know that cos squared A is 1 minus sine squared A. And you substitute that in here, which gives you cos 2A is 1 minus 2 sine squared A. So now we have this equation here, 2 sine x plus 12 sine squared x minus 5. Now, If we look at our equation is sine x minus 3 cos 2x. We're going to have to get clever here. We have to find the connection between part C and part D. So let's write the equation out first. Y equals sine x minus 3 cos 2x minus 0.5. Now, we know that cos 2x is 1 minus 2 sine squared, so we're going to insert that in. Equals sine x minus 3 times 1 minus 2 sine squared. And multiplying that out will give you sine x plus 6 sine squared x minus 3.5. So if you look at our graph is y equals sine x times 2 plus 12 sine squared x. Interesting. And it's minus x minus 5. So this is our graph, f of x. And so we need to figure out how to write this kind of a g of x in terms of f of x. So if we double this, we could say g of x is equal to 2fx. 2fx would be 2 sine x, good, 12 that, and minus 7. So what we need to do, we need to minus x, and to turn minus 7 into minus 5, we need to plus 2. Now we need to make f of x our solution, function. So we need to rearrange that. So we make it equal to 0. So therefore 2f of x is x minus 2. Therefore f of x is equal to half x minus 1. We have this, we need to draw this. So we're drawing the line y equals a half x minus 1. You draw that on the graph and you get your solution. Okay? Minus 1, 1 across, half down, 1 across, half down, 1 across, half down. That's your line, roughly. And the solution will be about 0.5 and about 2.8. Approximately. Okay, next question. So trigonometric equations. This one's clever. So we know sine 2 theta minus 20 minus root 3 cos 2 theta minus 20 equals 0. So that's equal to 0. So let's put that on the other side. And you end up with sine 2 theta minus 20 is root 3 cos 2 theta minus 20. Now if you divide by cos, you get sine 2 theta minus 20 over cos 2 theta minus 20. And you should remember that sine over cos, if the angle is the same, is just tan. So tan 2 theta minus 20 is equal to root 3. So you do shift tan of root 3. So make sure your calculator is in radians mode. I'm just doing that now. Shift tan root 3. It should give you pi over 3. Oh, wait, this is in degrees actually, so you need to be in degree mode. So that's going to be 60. So 2 theta minus 20 is 60. So 2 theta is 80. So theta equals 40. So we need to check, are there any other solutions? So from 0 to, so let's have a look at this. So we have 0, theta, 180. We want to do 2 theta. So first we're going to double. And then we're going to minus 20. So minus 20. So we're looking for answers between minus 20 and 340. Now remember, tan repeats every 180 degrees. So if you add 180 to this, you'll get 220, which is within the range. If you add 180 to that, you'll get 400, which is rejected. So that's outside of the range. So these are the solutions. If you look at the wording in the question, yep, so you're finding all of the solutions. Okay, last question. OA is 2A, OB is 4B. Find AB. So let's write it in capital letter mode. So AB is AO plus OB. AO is minus 2A plus 4B. That's it, 2 marks for that. Practically giving marks away. P is the midpoint of AB. Find OP. So if you're going to go from O to P, you're going to go from O to A, and then from A to P. Now OA is just 2A, and AP is a half AB. Yeah, because it's a half of the way from A to B. So that's going to be 2A plus a half of this, so minus A plus 2B. Yep, so half of AB. So that's going to be A plus 2B. Point Q lies on OP such that OQ to QP is 3 to 1. OQ to QP is 3 to 1. Yep, so we've broken it into those parts. Find AQ. So you would go from A to O, and then O to Q. AO, as you know, is minus 2A. And OQ is what fraction of OP? Well, it's 3 out of 4. Oh, that should be capital A. Okay, so that's going to, sorry, actually, these should be small a's, my mistake. So it's minus 2a plus 3a over 4 plus 3b over 2. Simplifying that, that's minus 8 plus 3, so it's minus 5a over 4 plus 3b over 2. So how we find AQ. Point R lies on OB such that AQR is a straight line. Find the ratio of OR to RB. Okay, so AQR is a straight line. So we know that AQ is minus 3a over 4 plus 3b over 2. And we know that QR is some multiple of that. So let's say, so QR is k times minus 3a over 4 plus 3b over 2. But if we look at the vector OR, it is only in terms of b. Okay? So it's only some multiple of b. So OR is OA plus AR. And OA is 2A, so and AR is just AQ plus QR, so add these two together. And that's going to be equal to some multiple of B. That means that all of these terms in A should cancel out. So 2A minus 3A over 4 minus 3KA over 4 equals 0. So multiply everything by 4 and you get 8A minus 3A minus 3KA. So 3KA will be equal to 5A. So therefore K equals 5 over 3. So K is the multiple. Now we can put that in here again and find our coefficient for B. So the number of B's in the question are this term and this term. Yeah? And we know that when we add them together, we will get 5 over 3. So 3B over 2 plus 3 over 2 times 5 over 3b, and add them together, so those 3's will cancel. So 5b over 2 plus 3b over 2 is 8b over 2, which is 4b.